Hey guys, this is Professor Janacek, and I want to go over integration by substitution. This is often referred to as u-substitution because we often will use u as our new variable. The first thing to recognize when doing this integration by substitution is that we start with the composition of functions, and our u value is the inside function. That's going to be how we select u. The other thing to make note of is when we replace g of x with u, then in the back what we now need is du. That du ends up including g prime of x dx. This comes from the idea of the chain rule from derivatives. This is an antiderivative of a chain rule, and if you recall with the chain rule you always had to multiply by the derivative of the inside function. Well, now we're undoing that, so we have to start with that little derivative out there. So let's dive in and take a look at some examples and see if this makes sense to you guys. So we're going to integrate, for example, 1, integrate 2 times the quantity 2x plus 1 raised to the third power dx. So we will start by selecting a u. Remember, u is the inside function of our composition. That is 2x plus 1 in this case. Now, if that's the situation, then what is du? Well, du is the derivative of 2x is just 2. The derivative of 1 is 0, which we don't need to write, but we do have to write this dx here. Make sure you understand that if I were trying to determine if I were wanting to find du dx, that's just 2. However, du is 2 dx. Back when we were talking about derivatives, we would also often look at du dx. But now we're just looking at du. So make sure you understand the difference between du dx and just du. Du does include that dx there in the back. All right, so using that substitution, I realize that my du, the part in the back, is going to have to be 2 dx. Right now, in the back, I only have a dx. So let's take this 2 that we have in front and put it there in the back. So I'm going to start by just rewriting this as the integral of 2x plus 1 quantity cubed, and then we have the 2 dx in the back. Now notice I have a direct substitution. This 2x plus 1, that is u, and it is cubed. Now in the back, 2x dx, that is du. So we can integrate this. We could definitely find the antiderivative of u cubed. That is 1/4 u to the 4th plus our constant. Don't forget about that arbitrary constant out there. The integral of 0 is a constant. And then we simply go back and resubstitute for u. We have 2x plus 1. That gives us 1/4 times 2x plus 1 to the 4th power plus c. And there we go. Let's take a look at the second example where we have the integral of 10e to the 10x dx. Again, we'll let u be the inside function. Now this one's a little more complicated to see. I have the e function, but notice inside that e function, the inside is the exponent, and that exponent is 10x. So we'll let u be 10x. Then what is du? Well, du is 10 dx. Again, I see in the back with du, I'm going to need a 10 dx. So the first thing I'm going to do with this dx, I'm going to move that 10 over there. Fortunately, we've got that 10 to work with. If we didn't have this 10, we might have to finagle something a little differently. So I've got e to the 10x, and then this 10 dx is all there in the back. Now I can rewrite this in terms of u. This is the integral of e raised to the u, because u is 10x, and now here in the back 10 dx, that's all du. We can integrate this. The integral of e to the u du is simply e to the u plus the arbitrary constant. And now let's go back and replace u with x, because we started with x's, we now need to end with x's. So we have e to the 10x plus c. All right, not so bad, I hope. Maybe you're starting to get the hang of this. Let's take a look at example 3. We will integrate x to the 4th times the quantity x to the 5th plus 9. That quantity is raised to the 9th power. I'm sorry, x to the 6th, x to the 5th plus 6, yeah, raised to the 9th, and then dx. So, to begin with, u is the inside function of that composition. So that looks like x to the 5th plus 6 would be a nice value for that. Then from this we can determine du. Let's see, x to the 5th gives us 5x to the 4th. 6 is a constant, the derivative of that is 0. And then of course we still have dx. All right, so this one's looking a little different. So I know in the back with du, I'm going to need the 5x to the 4th dx. I have a dx in the back. I can take this x to the 4th back there, but I don't have the 5. So let's talk about how to get that. So I'm going to rewrite this. I'm going to still take this x to the 5th plus 6, write that first. There's my u. Now in the back, I need a 5x to the 4th dx. That is what I'm being told here from du. That whole thing has to be there. But the 5 is what's missing. I can't just multiply by 5 whenever I want. So to balance this out, I'm also going to divide by 5. Now, I could have divided by 5 over here. I could have done something like just divide by 5, right? 5 over 5 is 1, but I don't want it. I don't really need that 5 in the denominator there, so I'll go ahead and factor that out and put it here in the front. So now when we rewrite this, we have this 1/5 out in front of the integral. Substituting for u, we get u to the 9th, and now we have du all in the back, which is really nice. When we integrate, we still have this 1/5. Integrating u to the 9th du gives us 1/10 u to the 10th plus a constant. Now, it is true that that constant is being multiplied by 1/5, but 1/5 times a constant is still a constant, so I'm just going to call it all c out there by itself. Well, it looks like we can rewrite this as 1/50th u to the 10th plus c, and then we'll rewrite this using x to the 5th plus 6 for u. And there we go. Make sure you understand that up there in that exponent, this is a 10. There we go. All right, let's take a look at one more example of an indefinite integral. Example 4 here, we have the integral of cosine cubed x sine x dx. First thing to notice here is that I can write this as cosine of x cubed and then sine x dx. So looking at it this way, our u value, again, inside the composition, looks like the inside function there is the cosine function. And so we'll let u equal the cosine of x. Then what is du? Well, du is negative sine x dx. Watch that negative. So what we need here, in order to do the substitution, again, I have u, which is the cosine of x, raised to some power, that's fine, but in the back, what I really need is du. I really need a negative sine x dx. So to make that happen, I'll put that negative in there, but I can't just go putting a negative in wherever I want. I'm going to have to balance it by multiplying a negative out here as well. Now when I look at this substitution, still have this negative out here, we have the integral of u cubed du there in the back. Well, if we integrate that, don't forget we still have this negative in the front. The integral of u cubed du is u to the 4th over 4 plus our constant. Of course, I'll write that as negative 1/4 u to the fourth plus the constant. And then finally, we'll rewrite this, replacing u with the cosine of x. So we have negative 1/4 times the cosine of x to the fourth plus c. Again, that negative would get distributed to the c, so you could technically write minus c instead of plus c, but perhaps c is a negative value, so we'll let that constant absorb that negative as well. So this can be rewritten as negative 1/4 cosine to the fourth x plus c. And there you go. Enjoy.